In this video, we will continue to practice graphing sine and cosine functions with changing amplitude and period. So, looking at problem number 6, we see the a value right there, which controls the amplitude. So the amplitude will be 1/2. Now we see the b value right there. The b value controls the period in the following way. The period is always equal to 2 pi divided by the b value. So since the b value is 4, that means the period is going to be 2 pi divided by 4. Now both of these are divisible by 2. Alright, so basically if you reduce this, you find that the period is pi over 2. So the period will be pi over 2. There is no phase shift because nothing is being added or subtracted. So for phase shift, we will just say none. This is enough information for us to draw the sketch of the graph. Since the amplitude is 1/2, I will put positive 1/2 up there, and I'll put negative 1/2 down here. The period is pi over 2, so way over here on the right, I will put pi over 2. Halfway along, I will put pi over 4, because that's half of pi over 2. And half of that should be pi over 8. Half of a fourth is an eighth. But what about this third one? Using the smallest interval to count, alright, my smallest interval is pi over 8. So I will think 1 pi over 8, 2 pi over 8, 3 pi over 8. And that's how you can find the name of that position. The sine function always is going to start off here at 0, and then it will go through its pattern. So it should go up to its maximum value, and then back to the midline, then down to its lowest value, and back to the midline. So this will be a nice graph of this sine function. Alright, let us look at number 7. The a value is right here. Now that a value tells us two things. First of all, even though it is a negative 4, the amplitude is still positive 4. Amplitude is always positive. The period is not affected by the amplitude. However, when we do the graph in a moment, please understand that this negative sign means that it is a reflection over the x-axis. Alright, so keep that in the back of your mind. Now the b value would be right here if there was one. But the lack of a number tells us that the b value is 1, which means that the period is unchanged and should still be a regular old 2 pi. There is no phase shift since nothing is being added or subtracting on the end. So for phase shift, we will just say none. This should be enough information for us to draw the graph. Okay, since the amplitude is 4, that means it will go up to positive 4 and down to negative 4. Since the period is 2 pi, that means way over here I will go ahead and say 2 pi. Now, right in the middle, this should be pi. Half of that should be pi over 2. And between these, I should have 3 pi over 2. Now, this is a sine function. And a sine function is always going to start right here from 0. Now, normally a sine function goes up and then back down, and then it goes down to its minimum and then back up to the midline. This is what it would normally do. However, this is a reflection over the x-axis because of this negative sign. So, for that reason, instead of going up, we should go down. So first the sine function will fall, and then return to the midline, and then rise, and then return to the midline. So this is what it will look like because it is reflected over the x-axis. All right, that's what number 7 should look like. Let's talk about number 8. The a value is right here, or it would be. Since the a value is 1, that means the amplitude is unchanged. Amplitude is 1. The b value is right here. This is interesting. The b value is going to affect the period. Because it's negative, though, in addition to changing the period, a negative sign right here is a reflection over the y-axis, so that should be interesting. All right, let me just write that down. This should be a reflection over the y-axis. Weird. Anyway, let's talk about the period. The period is always going to be 2 pi divided by the b value. Now ignore the negative sign. So, I guess technically I could say the absolute value of the b value. So the period is going to be 2 pi divided by 4. And this is going to reduce down to pi over 2. So the period is pi over 2. There's no phase shift because nothing is being added or subtracted. So for phase shift, we will say none. This should be enough information for us to draw the sketch. All right, now normally I put the y-axis over here and I put the entire graph on this side. This time I'm going to put this line more in the middle to leave room for a reflection over this y-axis. Interesting. So the amplitude is 1, so that means it will go up to 1 and down to -1. The period is pi over 2. So over here I'm going to go ahead and put pi over 2. Then halfway I'm going to have pi over 4. Then half of that would be pi over 8. And then right here, this is 1 pi over 8, 2 pi over 8, 3 pi over 8. So 3 pi over 8. Now because I know I have a reflection over the y-axis coming, I'm going to go ahead and label these as well. But this would just be negative pi over 8 and negative pi over 4 and negative 3 pi over 8 and negative pi over 2. Now I am all set. Okay, so guys, if I didn't have the negative sign right here, let's talk about what would happen. This is the sine function. So I start from 0, and I would go through the normal pattern. Okay, I would go up to its high point, and then back to the midline, and then I'd go down to its lowest point, and back to the midline. That's what I would have if there was no negative sign right here. Now, because I do have a negative sign right here, then that tells me that I need to do a reflection over the y-axis. So I'm going to find the mirror image of each one of these points. Now, the reflection of the point that's right on the y-axis, that's not going to change. But the mirror image of this on the other side of the y-axis would be here. The mirror image of this point would be here. The mirror image of this point would be here. And the mirror image of this point would be here. So this blue pattern is going to represent the actual graph. So it's going to look like this. Okay, so again, it was just the normal graph that I would have without this negative sign, but reflected over the y-axis. Okay, let's take a look at number 9. All right, so right here I've got my A value. That tells me that the amplitude is going to be 3. Right here I've got my B value. Because it's invisible, I know that's a 1. That means the period is unchanged from the parent function. So the period will be 2 pi. There's still no phase shift because nothing is being added or subtracted on the end. That should be enough information for us to sketch this graph. Since the amplitude is 3, it's going to go up to 3 and down to -3. Since the period is 2 pi, then I'm going to put 2 pi over here. And then halfway I'm going to put pi. Then half of that will be pi over 2. And then between here I will have 3 pi over 2. Now this is a cosine function. So the cosine function starts off up high at its maximum value. And then it falls from there. So it should start off here, and then it should fall to the midline. And then here it falls to its lowest value, and then back to the midline. And then at the end of this period, it's back up at its highest value. So this is what this cosine function should look like. All right, there's one period of this cosine function. All right, let's go ahead and do problem number 10. The A value would be right here. The invisibility of the A value tells me that it's a 1. So the amplitude is going to be 1. Right here is my B value. And the B value controls the period. So the period is always equal to 2 pi divided by the B value. So the period will be 2 pi divided by 3. All right, that's interesting. So that's my period. So the period will be 2 pi over 3. The phase shift will be none because nothing is being added or subtracted on the end. So no phase shift yet. All right, so these numbers may be a little bit ugly, but we are ready to sketch the graph. The amplitude is 1, so that means I'm just going to be going up to 1 and down to -1. The period is 2 pi over 3. So I'm going to put this here, 2 pi over 3. Now, right in the middle, I'm asking myself, what's half of 2 pi over 3? So look, if I take 2 pi over 3 and I multiply that by a half, can you see that I'm going to get 2 pi over 6? Okay, so, but this reduces. 2 goes into 6 3 times, so this is pi over 3, which makes sense. If this is 2 pi over 3, of course half of that will be 1 pi over 3. All right, now I need to take that and cut it in half. Half of pi over 3 is pi over 6. Now, what will be halfway between these two? You can think of it this way. This is 1 pi over 6. This is 2 pi over 6. This will be 3 pi over 6. Okay, but this does reduce, doesn't it? 3 goes into 6 twice. So this is actually just pi over 2 once you reduce it. So 1 pi over 6, 2 pi over 6, 3 pi over 6, but that reduces down to pi over 2. So this is how the x-axis should be labeled. All right, the rest is absolutely normal. This is a cosine function, and we know the cosine function should start off at its highest point and then drop from there. So it should go to the midline, and then to its lowest value, and then back to the midline, and then to its highest value. All right, so this is what the cosine should look like. All right, and that is number 10. And that's enough for one video, so I'm going to stop this video right here.